Welcome to this tactical briefing. Today, we're diving into a really powerful high-performance command in our arsenal, copyWithin. Now, this is a tool that can save a mission in seconds, but you gotta know, one wrong move can have absolutely catastrophic consequences.
Okay, so let's get right into this with a huge warning right up front. I want you to pay close attention to that last part. There is no undo. This method is what we call mutable, which is just a fancy way of saying it permanently changes your data. The second you run this command, the original data in those overwritten spots, it's just gone, for good.
So before we can even think about using it, we have to understand what we're dealing with on a fundamental level. Look, this isn't about making new things, it's all about reconfiguring what you already have and doing it with incredible speed. At its core, copyWithin takes a piece of your data array and it pastes it somewhere else, but, and this is the key, inside that very same array. Notice that emphasis on same array. This command is all about realigning data internally. It doesn't give you a nice, new, separate copy to work with safely.
And here's a really crucial point. No matter how much you shuffle the contents around, the size of your data structure stays exactly the same. The array's length doesn't grow, it doesn't shrink, its whole integrity, you could say, is preserved. You're just rearranging all the components inside.
Okay, let's move on to the command structure and see how this thing is built. To use this tool effectively and, more importantly, safely, you have to know these parameters with absolute precision. There is literally no room for error here. So, the command takes three parameters. First up is the target. That's the index where you want to start pasting your data. This is the only one that's required. Then you have start and end, and these define the slice of the array you want to copy. Now, if you leave them out, it just defaults to copying the entire array.
All right, enough theory. Let's get into some live-fire simulations. Because, theory is one thing, but seeing it in action is something else entirely. Pay close attention to how the data buffer gets altered in these next two scenarios.
Okay, your first simulation. The USS Enterprise has taken damage to its rear shields. Power levels are critical. We need to restore protection, like right now, by copying the harmonic frequency from the undamaged forward shields.
So here's the situation. Our front shields at index 0 and 1 are solid at 100%, but the rear shields at index 2 and 3, they're failing. So the maneuver is to copy the data starting at index 0 and ending right before index 2, and then paste it at our target, which is index 2.
And boom, look at that. It's a perfect example of a successful realignment. The command executes, that damaged section gets completely overridden with the stable data, and full protection is restored across the ship. Just a perfect high-speed solution. All right, next up, a medical tricorder simulation. So this device keeps a rolling log of the 5 most recent biosigns. What we need to do is duplicate the first 2 readings to calibrate a sensor, which means we have to overwrite the 3rd and 4th slots. Now watch this closely. The initial buffer is full, right? We run the command to copy the elements at index 0 and 1, and we paste them starting at index 2. And as you can see, the gamma and delta readings, they've been permanently overwritten by a copy of alpha and beta. The array's length is still 5, but the data inside, it's changed. Okay, now for what is probably the most important directive of this entire briefing, understanding the danger that is built right into this command. Forgetting this next part can lead to some truly irreversible data loss. So, let me ask you a question to frame this. Imagine you're in the command chair, looking at the ship's primary navigation array. You need to plot a return course to Earth, and you think, hey, I'll use copyWithin to duplicate the coordinates. What happens to the data you just pasted over?
They're gone. Forever. I mean it. In this example, by copying Earth into that second position, the coordinates for Vulcan were just purged from the system's memory. This is the prime directive of data. copyWithin is destructive. You have to assume the data you're pasting over is going to be lost for good. And here is a fantastic analogy to help you remember this. Think of it like a transporter. Some commands might create a clone, giving you 2 captains. But copyWithin, it's different. It beams the captain into the sickbay, and in doing so, it completely erases the doctor who is standing on that spot. It doesn't add, it replaces. So you're probably thinking, if this thing is so dangerous, why is it even part of our standard toolkit? Why not just use a safer method? Well, the answer, in one word, is performance. See, unlike a standard for loop, which would have to painstakingly move items one by one in your code, copyWithin operates at a much, much deeper level.
It's a command that talks directly to the JavaScript engine, which is often implemented in a super fast, low-level language like C++.
It performs what's known as a memory block copy. So instead of picking up each little piece of data individually, it just grabs the entire section in one go and moves it. When you're dealing with huge data sets, this operation is orders of magnitude faster. When you're dealing with millions of records, think about reorganizing transporter pattern buffers or sensor logs in real time. That performance difference isn't just a nice to have, it's mission critical. And that is the reason we accept the risk.
So if you remember nothing else from this briefing, remember this phrase. CopyWithin does not make the array bigger. It doesn't add new chairs to the deck, and it doesn't remove them. It just takes some chairs from one side of the ship and puts them on the other, forcing whoever was sitting there to get up.
And that really leaves us with the final question, which isn't for me to answer, it's for you. This tool is in your hands now. You understand its speed, and you understand its danger. So your mission is to use it with precision and with caution, and to always weigh the trade-offs. Briefing concluded.